Good morning. Welcome to Rogini College of Engineering and Technology. I am Reggie, Associate Professor, Department of ECE. Today we are going to discuss about reflector antenna. Reflector antenna. From this, students can able to define reflector antenna, design of antenna parameter like gain, bandwidth and directivity. Reflector antenna are widely used to modify the radiation pattern of the radiating element. For example, radiation from the antenna may be illuminated with a plain sheet of enough dimension. In the more general case, a beam of predetermined characteristics may be produced by a beam of large suitable shaped and illuminated reflector surface. Reflector antenna is basically a combination of feed and reflecting surface to achieve high directivity at microwave frequency. This feed is known as primary antenna and it is a slot, dipole or horn antenna. The reflector is known as secondary antenna and it is a metallic plate which is curved or flat and used to direct the incident energy in specific direction. Application: it is mainly used in radar, radio astronomy, microwave and satellite tracking. Various reflector at various shape: large sheet, small sheet, the linear reflector element or linear element driven reflector of various shape. Figure A shows that large flat sheet reflector near a linear dipole antenna to reduce the backward radiation. With enough spacing between the antenna and sheet, this arrangement also yields a substantial gain in the forward radiation. The desirable characteristics of the sheet reflector may be largely preserved with the reflector reduced in size as shown in figure and even in the limiting case of figure. Here the sheet has degenerated into a thin reflector element, whereas the property of the large sheet are relatively insensitive to small frequency changes. The thin reflector element is highly sensitive to frequency changes. Figure shows that active corner reflector, passive corner reflector and parabolic reflector are the three type of reflector what we are used. If you take reflector at various shape with a two flat sheet intersecting at an angle alpha is greater than 180 degree, a sharper radiation pattern that from a flat corner can be obtained. This arrangement called active corner reflector antenna. In most practical way, the aperture is 1 or 2 lambda or of convenient size. A corner reflector without excitation antenna can be used for passive reflector or radar base. In this application, the aperture may be used many wavelength and the corner angle is always 90 degree. Reflector with the source having property that is incident wave is reflected back towards its source as shown in figure, the corner acting as retro reflector. Parabolic reflector can be used to provide highly directional antenna shown in figure F. The parabolic reflector reflected the wave originating from the source and focus into the parallel beam. The parallel transformation, the curved wave front from the feed antenna is focused into the plane wave front. If you see the point of the figure, here reflect driven element ellipse, hydraulic reflector and circular reflector with this driven element. Reflector at various stage. Many other shape of reflector can be employed for special application. For instance, with an antenna at one focus, the elliptical reflector as shown in figure produce a diverging beam with the reflected wave passing through the second focus of the ellipse. Examples of reflector of other shape are hyperbolic and the circular reflector as shown in figure. Parabolic reflector. It is the most important parabolic reflector are used in day-to-day application. The surface generated by the revolution is parabola. I wrote it axis, so it is called paraboloid or paraboloid of revolution. If an isotropic source is placed at the focus of parabolic reflector as in the figure A, the portion A of the source radiation that is intercepted by the parabolic is reflected as the plane wave of circular cross section, provided that the reflector surface deviated from true parabolic surface by no more than small fraction of wavelength. If the distance L between the focus and vertex of the paraboloid is an even number of lambda by 4, the direct radiation in the axial direction from the source will be opposite phase, will tend to cancel the central region of reflected wave. However, when L is equal to n lambda by 4, where n equal to 1, 2, 3, the direct radiation in the axial direction from the source will be in phase and will tend to reinforce the central region of the reflected wave. When you see the probability, the parabolic reflector at a different focal length will be source of different pattern. Parabolic reflector. Direct radiation from the source can be eliminated by means of directional source or primary antenna. A primary antenna with idealized hemispheric pattern results in a wave of uniform phase over the reflected aperture. Hence, the amplitude is tapered as indicated. To obtain more uniform aperture field distribution illumination, it is necessary to take theta 1 as small as suggested in the figure C by increasing the focal length while keeping the reflector diameter. A typical pattern of directional source can be indicated by a dash curve. It gives more tapered aperture distribution as shown in dashed curve. The greater amount of taper will result reduction in edge illumination may be desirable in order to reduce minor lobe level, this being achieved at sacrifice in directivity. Parabolic reflector a different focal length with a different pattern source. It is having the primary pattern and relative field intensity at the other side. When the parabolic reflector with a different focal length can be illuminated in the figure with a tapered illumination with a dashed primary pattern. Parabolic reflector will have the frequency f by d ratio. The surface of the paraboloid is found by rotating the parabola about the axis. Its surface may be paraboloid or revolution so that the ray emanating from the focus of the reflector are transformed into plane wave. The design is based on optical techniques and it is taken into account by deformation. Referring to the figure, OP plus PQ equal to constant which is equal to 2f. So OP equal to R dash. So cos theta dash is equal to P2 by OP. PQ by R dash. PQ is equal to R dash cos theta dash. So F by D ratio, when you increase the focal length, the dimension of the paraboloid is shown in figure. So the value cos theta dash is equal to R dash is equal to 2f by 1 plus cos theta naught, which is equal to f into secant square cos theta naught by 2. Since the paraboloid is the parabola of evolution, above equation can be also written as in terms of spherical coordinates. So R dash plus R dash cos theta naught equal to square root of z dash square plus y dash square plus z dash square plus z dash equal to 2f. So from this the value of another expression that is usually very prominent in the analysis of reflector will be theta naught is equal to tan inverse of d by 2 z naught, where z naught is a distance from the axis of the reflector from the focal length. So similarly we can compute the value for different ratio of different value for theta naught. So f is finally we will get the value f is equal to d by 4 cos theta naught by 2. Feed for parabolic reflector, axial bar front end. The overall radiation characteristics of the reflector can be improved. The structural configuration is upgraded. If it is shown that geometric optical, that is the beam of parallel rays, is incident upon the reflector whose geometric shape is parabola, the radiation will coverage at the spot which is called focal length. In the manner, if the point source is placed at the focal length, the ray reflected from the parabola will emerge on parallel beam. This is one of the principles of reciprocity and is determined in shown in figure. The symmetrical point of parabolic surface is a vertex. Rays from emerge in parallel transformation are usually said to be culminated. So axial front end is shown with vertex at the center. Axial front end, what are the drawbacks? The presence of primary antenna of the reflected wave has two principal disadvantages. Wave reflected from the parabola back to the primary source produce intersection and mismatching. Primary antenna act as the obstruction, blocking of central portion of aperture, increasing the minor lobe. That is called aperture blockage. So feed for parabolic. The disadvantages of front end is the transmission of line feed must be usually long to reach the transmitting or receiving equipment is provided by the reflector. So however, in most of the application, the transmitter or receiving equipment is placed at the focal point to avoid the need for long transmission. Offset to eliminate some of the deficiency of symmetry configuration, offset parabolic reflector has been developed for single and dual reflector. Offset reflector reduces design aperture blockage and VSWR. However, the reflector configuration generate cross polarized antenna radiation eliminated with a linearly polarized primary field. Circularly polarized field eliminate depolarization. It is square to quitting the main beam. So feed of offset field, cross grain field. Another configuration that avoid placing the feed at the focal length is shown in the figure. It is called cross grain field. Through geometric observation, cross grain, a famous astronomer, showed the incident parallel wave can be focused at a point to utilize two reflector to accomplish the main reflector by a parabola, secondary reflector a hyperbola, and a feed along the axis of the parabola. Cross grain used this scheme to construct optical telescope, and the design wave can be copied for radio frequency. The figure shows the application of cross grain. Cross grain for this arrangement, the ray denominator for the feed illuminate the sub-reflector and reflected in the primary reflector. Diffraction occurs at the edges of the sub-reflector and primary reflector, and they taken into the account to accurately predict the overall system pattern. Even in region of high intensity, diffraction may be included if the accurate formation of fine ripple structure of the pattern is desired. So most of the cases, feed structure of parabola are shown. Feed structure of parabola. One of the another reflector arrangement is the classical Groyan design as shown in the figure, where the main reflector is parabola while the sub-reflector is concave. The figure shows the Groyan field distributor. So what are the application of reflector antenna? Types of feeders in reflector antenna. Thank you.